Hello, welcome to this short session. I would like us to discuss angle properties of a circle. This is a mathematics topic in high school in the Kenyan secondary school curriculum. Let's start with the basic definitions. We have an arc, which is defined as any portion of the circumference of the circle. We have a chord defined as a line joining 2 points on the circumference of a circle. Then we have one special chord. A chord that passes through the center of the circle is called the diameter. Then we have a segment. A segment is a portion of the whole circle. When you draw a line, that is a chord, it divides the circle into two parts. The diameter will divide the circle into two equal parts, while another chord will divide the circle into two parts, which will be bigger than the other one. The bigger one is called the major segment, and the smaller one is called the minor segment. So this can be well shown by this diagram. The line AB, the red line, this is a chord, and I've named it chord AB. Then it is dividing the circle into two equal parts. We have this bigger part here, which is the major segment or the bigger segment, and we have the smaller part, which is the minor segment. If we draw another line, maybe from A, for instance, from A, then we draw a line. From A, then through the center of the circle to another point on the circumference. If we say this point is the center of the circle, we call this point C, then AC will be the diameter. And now to cut the circle into two equal halves. So now arcs. Arc we said is just a part of the circumference. So this is from A through C through B. That is an arc. And because it is a shorter arc, we call it the minor arc. The same, the distance A to D, then from D to C to B, that's also an arc. And because it is a bigger arc or the longer arc, we call it the major arc here. So those are basically the terms that we're going to be using to define the angle properties and their relationships in a circle. So let's get into the first angle property. So angles subtended on the circumference by the same arc or the same chord. So here we have this chord. We have this chord, the one that is painted green. And we can say that this chord is subtending these two angles, angle A and angle B, on the circumference of this circle and on this segment here. So because these angles are made on the circumference by the same chord or by this same arc here, then we say that angle A will be equal to angle B. Reason being, they are subtended on the circumference by the same chord. A point to note: the angles must be on the same segment. Must be on the same segment. Same segment of the circle. So this arc, if it subtends another angle on this alternate segment, this angle will not be the same. These angles will not be equal. This angle will not be equal to this and will not be equal to this because they are subtended on alternate segments. But these two are going to be equal. So the angle subtended on the circumference should also be on the same segment of the circle. Let's go to the second property. Angle subtended on the circumference by diameter. We define diameter as the chord that passes through the center of the circle. Because O is given as the center, then AB is going to be the diameter, and if you measure these two angles, they are going to be both 90 degrees. This is something you can just do practically. Draw a circle of your own radius, and using the diameter, subtend or make two angles on the circumference of the circle and measure the two angles. You realize that the angles are going to be right angles. These are properties that are verifiable practically. This should be 90 degrees. 90 degrees. I forgot to edit it, not 900. The next property, angle subtended at the center and at the circumference of a circle by the same chord or the same arc. So here our chord is AB, and also the arc is also AB. So this arc or this chord AB is making this angle Y at the center, and also making this angle X at the circumference. If you measure these two angles, this angle will be half of this. So for instance, if this angle is 120 degrees, you realize this will be roughly around 60 degrees if you try this practically. So you say that the angle that is made at the circumference is half the angle that is made at the center by the same arc. Or the vice versa is also true. We can say that the angle that is made at the center is twice the angle that is made at the circumference. It's the same as saying that half y just be the same as x. It will just mean the same. So angle subtended at the center and the circumference is half the angle subtended at the center of the circle by the same chord or the same arc. The next property, angle subtended on alternate segments of a circle. So our chord of reference here is chord AB. Then the tangent line that is drawn here and named here. So this is the chord we are going to be using. So this chord is subtending these two angles here. It's subtending this angle X in this segment, this major segment. Then it is also subtending this angle Y in this minor segment together with the tangent of the circle at point A. So this angle is said to be subtended in the alternate segment to this angle y, and they are going to be equal. So angle x is the same as angle y. They are subtended in alternate segments by same code. So that's the relationship between the two angles. Let's look at the cyclic properties of angles in a circle. So if I call these vertices, if I name the vertices, I can name these A, I name these other vertex B, the other vertex I call it C, and then I call this D. Then ABC D is a cyclic quadrilateral. Why? All its vertices are touching the circumference of the circle. So for a quadrilateral to be cyclic, all the vertices must be on the circumference of the circle. So all these angles are called interior angles. X, Y, V, and W are interior angles, while angle S is going to be an exterior angle. So angle X and W are called opposite interior angles. This angle is opposite to this one, and they are called opposite interior angles, and they are going to be supplementary. That means angle X plus angle W, this will give you 180 degrees. Supplementary angles add up to 180 degrees. Likewise, angle V and angle Y are going to be again opposite interior angles, and likewise they're also going to add up to 180 degrees. They're also going to be supplementary. Plus angle V will also give us 180 degrees. Now, this angle and this angle are said to be angle X is the opposite co-interior angle to the exterior angle S. And how do we get angle S? By extrapolating any line of the cyclic quadrilateral. If we extrapolate that one, we'll end up with another angle here. Let's call it angle Q. We extrapolate this one, we get another angle, maybe angle M, and so on. We extrapolate, you can get another angle, maybe angle P. So the exterior angle is usually equal to its opposite interior angle. Exterior angle is equal to the opposite interior angle. That's why angle S, this angle S here will be equal to angle X. Likewise, angle M will be the same as angle W. This will be opposite to this one. Then angle P will be equivalent to angle Y. And angle Q, this one here, will be equivalent to this opposite interior angle, which will be angle V. All these are pairs of equal opposite and exterior, opposite interior and exterior angles. So that is the last property of angles. Let's now look at a few examples on how you can now be able to use these properties to calculate a few questions. Hello, welcome. Let's look at this question. It's a question on angle properties of a circle. It's a question I had given in a class as an assignment in a class I'm hosting on Google Classroom. In the figure below, P, Q, R, and S are points on the circumference of a circle, center O. The point TSO and Q lie on a straight line. MPT is a tangent to the circle at point P. So this is a diagram. And then the questions I have: find the values of the following angles and state reasons in each case. So the first angle is this angle here, angle SRP. Angle SRP will be this angle here. This is the angle we are looking for. So if we look at this angle, SRP, it is made on the circumference by the arc PS. The same arc PS is making this angle PQS. And we usually say that angles obtained on the circumference of a circle by the same arc are equal. So this angle SRP will also be 40 degrees. So this will be 40 degrees. And the reason we say here, it is made on the circumference, by same arc as angle PQS, which is equivalent to 40 degrees. So we've done the first angle. So the second angle is angle ORP. This is the angle we're looking for, angle ORP. So let's first look at a few other angles so that we can be able to get the angle ORP, because we cannot just get it so directly. This angle QOR, this is angle at the center of the circle, and this OQ and OR are going to be equal lines, because this will be a radius and this will also be a radius. So this will give us a QOR will be an isosceles triangle, and isosceles triangles, the base angles are equal. So this angle and this angle are going to be equal. Angles of a triangle add up to 180. So this angle plus this angle plus this angle should give us 180. So we can take 180, subtract 120, this will give us 60 degrees. And this 60 will be for the two angles, and they are going to be equal. So we divide by 2. So each is going to be 30 degrees. So this angle will be 30 degrees, and this other one will be 30 degrees. So now from here, let's look at the triangle QRS. This triangle here, triangle QRS. We are told O is the center of the circle. That means this line QOS will be the diameter. and usually say that an angle subtended on the circumference by the diameter is 90 degrees. So angle QRS is going to be equal to 90 degrees, so that it is made on the circumference by diameter QOS. So, and now this angle QRS is supposed to be made by these three angles. This angle SRP, this angle here, and this angle here, and this angle. So if I get 30, so that would mean 30 degrees plus angle ORP plus 40 degrees. This has to give us 90 degrees. So angle ORP be 90 minus 30 plus 40. This would be 20 degrees. 30 plus 40 would be 70. 90 minus 7 degrees be 20 degrees. Say 20 degrees. So we have found angle ORP. The next angle is angle RPT. Angle RPT. This angle here. Angle RPT. This angle we're looking for now here. So if we draw this angle or this circle without these so many other parts, I want to isolate a few parts. If I draw this circle alone, I draw line RP, R and P, then I draw the tangent PT. This is T and this is M. I draw PQ. And I join Q to R. This angle is related to this angle. So angle PQR be the same as angle RPT. Angles subtended on alternate segments of a circle by the same chord. So chord RP makes this angle together with the tangent on this minor segment of the circle, and it also makes the same angle PQR, this angle here, on the bigger segment or the major segment of this circle. So PQR is this angle here. PQR, it be this angle. So 40 plus 30, 70. This will be 70 degrees. So this will be 70 degrees. So angle PRT be 70 degrees. Say angle subtended on alternate segments of a circle, and we'll be done with angle RPT. So let's look at angle SPT, this angle here. STP. So we're looking for this angle here. STP, this angle we're looking for. So we already have this angle given us 70 degrees, and RP is a chord of this circle, just like QOS. So chords of a circle intersect at 90 degrees. So this angle is going to be 90 degrees. 90 degrees. STP. So this is 90. So looking at this triangle PST to be a right angle triangle, this will be 90, this will be 70. 90 plus 70, that will be 160. If you subtract from 180, this will give you 20 degrees. So the angle is going to be 20 degrees. STP. STP. That will be 20 degrees. If we get the angle QPM, QPM is similar to the angle that we found in part C, RPT. Because the QP is making this angle QPM on this minor segment of the circle, this one here, minor segment, minor. Then the same chord QP is making this angle QRP on the major segment. Remember, we found this to be, RP was found to be 20 degrees. So this in total will be 50 degrees. So this angle will in turn be 50 degrees. So this will be 50 degrees. Reason, angle subtended on alternate segments by same chord. They are the same as this one. There are two reasons. Get another question. In the figure below, TA is a tangent to the circle ABCD, the center O. Angle TAD is given as 40 degrees, and angle BOD is given as 116 degrees. So let's start with the first angle ACD. We are talking about this angle here. Angle ACD, this angle here. Get angle ACD, we need to find some other angles so that they can lead us to that angle ACD. Like we can get this angle BOBD. Looking at a triangle using triangle BOD, it is an isosceles. I don't know whether these are the correct spellings of an isosceles triangle, because this will be the radius of the circle, this will be the radius, because this is given as the center. That would mean this angle and this angle are going to be the base angles, and they're going to be equal. So to get the two angles, you take 180 minus 116. This is going to give you 64. You divide this by 2 and it will give you 32 degrees. So each of these angles will be 32 degrees. This will be 32 degrees. This one will be 32 degrees. We can as well get this other angle here using triangle ADT, angle ADT will be the same as 180 minus the sum of these two other angles here. Angle DAT is 48 and these are 26, minus 48 plus 26. This is going to be the same as 106. 106 degrees. 180 minus 74 to be 106. 106 degrees. Then looking at this other angle here, this angle here, angle ODA, it is on a straight line with this angle ODB, this one here itself, and these are 106 degrees angle. So we can say that angle ODA be given by angles on a straight line that add up to 180. So we subtract the two angles, 106 plus 32. That is be 180 minus 38, and that will give us 42 degrees. Yeah, this will be 42 degrees. 180 minus 138, this will give us 42 degrees. So looking at this angle, look at this angle, angle ADT and angle ABD. They are angles on the alternate segments of a circle because they are subtended by this chord AD on the alternate segments. So this angle will be 48 because this angle here is 48. So, and this is already 32. So 32 minus 48, this small angle here will be 16 degrees. 16 degrees. So that if you had this and this, they give you 48. 32 plus 16, they'll give you the 48, which will be equivalent to this angle. So we are looking for the angle ACD. And this angle ACD is subtended by the same chord or the same arc AD on the circumference as just the other angle DBA, this angle here. They are all subtended by the same chord or the same arc on the circumference. So this angle will still be 48. Angles subtended on the circumference by the same chord or the same arc are going to be equal. So this one is going to be 48 degrees. So if we look at the second angle, ABO, angle ABO, we've already found it is going to be 16 degrees. The other angle is ADO. ADO, we've already found it here. It is 42 degrees. And lastly, we have this angle ACB. ACB. This angle we're looking for here. ACB. ACB. This chord here, called BCD, is subtending this angle of 116 degrees at the center. The same chord is subtending this angle BAD still at the circumference. So the angle that is made at the center is always twice the angle that is made at the circumference. So this angle BAD will be half of 116, and that will be 58 degrees. So looking at the figure, ABCD is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral that all its vertices are touching the circumference of the circle, and that is the case for the quadrilateral ABCD. And opposite angles of a cyclic quadrilateral must add up to 180. So if we get angle C plus angle A, this has to give us 180 degrees. So angle A is 58. So angle C plus angle A, which is 58, this has to give us 180 degrees. So angle C will be 180 degrees minus 58 degrees. This will be the same as 122 degrees. If we subtract this from, but this angle, the angle C, this angle is angle ACD. This angle here is 40 degrees. So to get angle ACB, we need to subtract 48 from 122. So we subtract 48 here. This is going to give us 74 degrees. Going to give us 74 degrees. So angle ACB will be 74 degrees. The angle ATB is given, so there's no need of calculating it again. Let us look at the third question here. Probably the last example. In this figure below, ABCD is a circle with center O, AB and DC meet at point E outside the circle. Line DC is equals line BC, and the angle BCE is given as 40 degrees. So find the angles. Let's look at the different angles here. Angle BAD. Because you are given that AOB is the diameter, it's a chord passing through the center of the circle, then it is subtending this angle D, the chord AB via O is diameter because it is passing through O is the center. So now the same chord is subtending this angle here on the circumference of the circle. So this angle is going to be 90 degrees. It's going to be like 90 degrees. So BAD is going to be 90 degrees. See that subtended on the circumference by the diameter of the circle. Angle BDC, we are looking for this angle here. So if you consider triangle DCB, it has two sides that are equal. So this will be an isosceles triangle. An isosceles triangle, and these angles, this angle will be the same as this angle. And we can get this angle because this angle and this other angle are angles on a straight line. So angle BCD be given as 180. Angles on a straight line add up to 180. You subtract 48, and this will give us 132 degrees. So this angle here will be 132 degrees. So angles of a triangle add up to 180. So the two base angles of the isosceles triangle will be 180. We subtract 132, and this will give us 48 degrees. And because this is for the two angles sharing equally, we divide by 2, and each angle will be 24 degrees. So triangle BDC will be 24 degrees using figure or quadrilateral ABCD. It is going to be a cyclic quadrilateral. So angle A plus angle C must be 180 degrees. This angle here, angle C and angle A, they are going to be cyclic opposite angles. So if we take angle C, angle A plus angle C, which is 132 degrees, it's going to give us is supposed to give us 180. So angle A be the same as 180 degrees minus 132 degrees. So this will be 48 degrees. So this angle here will be 48 degrees. And now, because we're looking for this angle here, we can now use triangle AED. This triangle here, angle A, triangle AED. Here, this one. So this one is 48. This one will be 90 plus 24. So we can calculate this. So triangle angle A be the same as 180 degrees minus angle A plus angle D. So this will be 180 degrees minus angle A is 48. We subtract angle D. This angle here, which will be 90 plus 24, be 114 plus. So 114 plus 48 is 162. So this will be, the angle will be 180 minus 162. And this will be 18 degrees. So this angle here, the angle here will be 18 degrees. So BAC will be 18 degrees.